Thank you for the kind introduction. And it feels awesome to be in person, seeing all of you. For last 2.5 years, it's been virtual, so I couldn't see the confused looks, the nodding of the heads. So now I can tell if some of you are sleeping, I can put you on the spot and ask a question. But yeah, it feels fantastic to be here. Welcome to this session. Do not click ops your data infrastructure. If you want to ask questions, you don't need to wait till the end of the session. You can pause or stop me right away. Of course, we'll have some time at the end of the session for questions as well, but just wanted to get that out of the way. So 5 languages, yes, you can take that as spoken languages or programming languages. If it's programming languages, I have a soft heart towards Java, but yeah, feel free to ask me about other 5 spoken languages. So I work at a company called Ivan. We build and manage your data infrastructure based on open source technologies so that you can focus on your critical applications. I'm from the beautiful New Brunswick, which is in the east coast of Canada. It's beautiful with mountains and the Atlantic. If you like fish and chips, feel free to take a visit there. I focus on app and data infrastructure, and in my free time, I'm a pro bono career coach. What it means that I use my weekends and nights to review resumes of students and new grads to help them start a career in tech. So before life was complex and things were simple, we used to click. We used to click and create a service. Well, not easily. We used to click and create a ticket. The ticket went to someone in the ops team, and they created a VM and gave it to us. And that felt like magic. Even in the days of cloud and automation, we click. Whether it's a click to create a one-time service or a proof of concept, we still click. But we can only do so much by clicking. If you want to scale, you need automation for your infrastructure. So in today's talk, I hope to talk about infrastructure as code, which is a popular topic. But more importantly, I want to focus on the data side of infrastructure as code, talk about some of the concerns, and a way we can get started. So when we talk about infrastructure, typically we think about application infrastructure. So let's say you lay your core network, a VPC, then you can have an abstraction on top of that, maybe a security group, and you create your virtual machines. You put load balancers in front of your virtual machines. You can point your DNS to the load balancer. And let's say for faster delivery, you can have a content delivery network or CDN. But let's pause for a second and ask ourselves, why do we build applications? To move data. Whether it's your mobile banking application or an application that moves data between your enterprise data warehouse or cloud data warehouse, our applications move data, or JSONs more commonly. That's why it's important to talk about data infrastructure as well, besides talking about the cool application infrastructure like containers and such. So what is data infrastructure? It could be your streaming platform like Kafka. It could be your relational database, maybe PostgreSQL or MySQL. It could be NoSQL database or all of those combined. How about the networking services for your data? You could have observability services running, or you could have a vault service that's managing secrets for your databases. All of these combinedly are your data infrastructure. So now let's talk about infrastructure as code. And there are some principles. The first infrastructure as code principle is reproducibility. And it says that your infrastructure as code tooling should build and rebuild systems, and your engineers shouldn't fight over the choice of host names. We all know that the hardest thing in software engineering is naming things, and you don't want your engineers fighting over that. Next one is repeatability. Now, it's easy to click and create a one-off service. But what if you need to click and create 20 services? How about 20 services every day? And that doesn't become that easy. So that's why repeatability also touches on the point of idempotence, where How about if I click and or run a custom script multiple times? Is the result the same? So an infrastructure as code tooling takes care of that so that it checks the desired state and an actual state, and if the service is already there, it doesn't do anything. The third infrastructure as code principle is disposability. Now, in the cloud era, the failure of the underlying hardware is not a matter of if, but when. We should be able to handle the failure or change of the underlying hardware. It's just an abstraction. The fourth infrastructure as code principle is consistency. Now, we might have a dev, staging, and prod environment, but let's say if your vCPU, your memory, and the performance between these environments, if it's different, then it's difficult to predict the reliability of your running applications. And the final point is about expecting design changes. Now, when we're building a system, it's very difficult to predict how our users will be using the system or how the requirements might vary in the future. That might give us a tendency to design overly complex systems. Now, these overly complex systems are difficult to change ironically. That's why, in order to be able to change easily, we have to change frequently. So frequent changes mean that the changes will not be dreaded, but expected. I didn't come up with these principles. This is from the book, Infrastructure as Code by Keith Morris. If you'd like to read more, please refer to that book. However, there are some challenges around infrastructure as code. And when I mean challenges, there are some concerns. Sometimes it is valid concern. The first concern is resistance to learning. And now, in engineering in general, there's a saying that if my system is already working, let it working, don't touch it. But it's no fun if your production goes down and then you're trying to change the system. Of course, if the production goes down, you can always blame on the intern, maybe. So that's no fun, right? So resistance to learning is one of the main barriers to any change, not only infrastructure as code. The second and third point are similar, so I'll talk about that together. So that is configuration drift and duplication of work. By configuration drift, we mean that our running system or the actual state is different from our desired state. And that can happen because of duplication of work. One example would be one engineering team is trying infrastructure as code tooling, whereas some other folks are making manual change in the UI. And one of the speakers from yesterday was also highlighting this fact. And that could lead to configuration drift and duplication of work. However, if you're transitioning towards infrastructure as code, some configuration drift and duplication of work is expected. That is perfectly OK. As long as you have a strategy to move towards infrastructure as code, some duplication of work is OK. I'm not hinting that every single team and every single service will need to use infrastructure as code. It's just that having two always is not a good idea. There should be a transition period, and then hopefully, wherever it makes sense, it could be rolled out. The fourth point is security issues. Now, according to one of the report, one of two Terraform modules for creating resources in AWS, GCP, or Azure were misconfigured. Now, this misconfiguration led to some security issues. But these public Terraform modules are just like code we find on Stack Overflow. Would you get a piece of code from Stack Overflow and run it in production? I see some nods. Maybe yes, but maybe not, right? So similarly, we have to treat these Terraform modules like this. If it's publicly available, we have to vet it ourselves and make sure that it passes the tests, especially security tests. And the final infrastructure as code challenge is handling unicorns. Now, by unicorn, I'm not talking about those companies with certain valuation. I'm hinting to special cases. And you might ask, what's a unicorn, Dewan? I have a slide for that. I'm talking about databases, relational databases, and how can we do infrastructure as code without downtime? There are three concerns. First concern is, how do we perform a version upgrade without downtime? The second one is how do we prevent a version upgrade without downtime? And the last one is how do we change configuration? So let's start with the first one. How do we perform a version upgrade without downtime? A version upgrade could be major version upgrade or minor version upgrade. I know most of the folks are concerned with major version upgrade. With major version upgrade, there are very few cloud providers, almost none would guarantee zero downtime. There would be mechanisms to minimize downtime, but zero downtime with major version upgrade, at least I don't know if anyone is providing that. So it's not a fault of the infrastructure as code tooling, but rather than the process, which would mean that you need to expect some downtime. Let's talk about prevent version upgrade. How do you prevent version upgrade? Depend on the tool you choose, you can have a flag that says allow major version upgrade or allow version upgrade, and by default, this could be set to false. And only if you set it to true explicitly, then your tooling could do a version upgrade. So there's ways to prevent that mechanism as well. The last one is kind of a generic one, whereas change configurations, and change configurations could be a lot of things. So it could be minor configuration changes for which you don't need any downtime. But let's say if it's a major configuration change, like changing an instance type, changing subnet, or changing encryption settings, you can expect some downtime, and that's where you need to plan ahead and understand what's your maintenance window, what's your threshold. If you have some other means of pointing users to some other database or connection, that needs to be planned ahead. But again, all of these concerns, if you are not doing infrastructure as code tooling, if you're using, let's say, clicking, or if you had a custom script, if your database acted in a certain way, it's going to behave the same way if you're using infrastructure as code tooling. So it's not a matter of the infrastructure as code tooling part. With that, I'd like to introduce Terraform. Terraform is an open source infrastructure as code tooling that lets you define your cloud and on-prem resources. It lets you declaratively define the resources. That means it's human readable and also readable by machines. It's version control as well. One disclaimer that Terraform is just an example. You don't have to use Terraform. It could be any infrastructure as code tooling. But we talked about 5 principles. So as long as our tooling goes by those 5 principles, or the standard principle, it should be OK. Now, how does Terraform work? So Terraform has something called provider. And provider lets Terraform call any API. As long as there's an API, Terraform can leverage that to create resources. So this example is, let's say, Ivan Terraform provider. So it's sitting in the middle, and then it calls the target API, and then creates Ivan resources. I think there's over 1,700 providers, which lets you create thousands of resources. So now let's check how Terraform matches with all those principles we just discussed. So the first principle we discussed, if anyone remembers, it's reproducibility. So how easy it's to create and build resources. So this is a block of code. Even if you haven't seen Terraform code before, that's perfectly OK. If you see the highlighted line, so I try to do a service name. What's the name of my service? And here, I'm getting a variable, which is service underscore name and underscore prefix. My variable file is defined somewhere else. And let's say the variable is prod. And with join function, the name of the service would be prod-m3a. Now, this creates a consistent naming, and my engineers don't have to worry about what the name will be. So this is how I can ensure reproducibility. Again, there's a chunk of code there. You don't have to go through that. But what this code is doing, it's creating 3 PostgreSQL services across regions and across cloud providers. And let's talk about the repeatability and the consistency here. So repeatability means I can use this code and create service repeatably. If the service already exists, and if I reapply the code, the service will not be created duplicately. I can see that, or Terraform can see that the service already exists, and it'll say the service already exists. And by consistency is from the naming, or let's say the specific settings where termination protection could be true. if you have engineering teams across the board, they could follow the same consistent behavior. Now, the best way we understand something is by a demo. So I have a very small demo for you to make the point about Terraform and how it leverages the infrastructure as code principles. But before I show you a demo, I wanted to show you this architecture diagram of my poor drawing. What the setup is Apache Kafka Mirror Maker in the middle. So Apache Kafka Mirror Maker does cross-cluster replication for Apache Kafka clusters. This could be for disaster recovery or for data compliance reasons. So let's say on the left, we have a data center 1, which is my Apache Kafka source cluster, and I have a topic A there. And in the right, I have data center 2, which is my Apache Kafka target cluster. So what the mirror maker in the middle will do that it has a replication flow, and it will replicate or copy the topic or the messages in the topic in the target cluster. And the naming convention would be the source cluster dot the topic name. So this is the setup I have. And I'll use Terraform to declare the entire setup. And let's see that in action. So I'm using Ivan platform just as an example. You could use anything. It doesn't have to be Ivan. So here I have my kafka.tf. And again, if you haven't used Terraform before, it's perfectly fine. I'm trying to make the point about the principles of infrastructure as code. So I have the topic defined here, the source topic, the target topic. And you can see that the mirror maker.tf file has the mirror maker service. I have some integrations. So this integration means the source cluster to the mirror maker service, and from mirror maker to the target cluster. And this defines the resource, which is a replication flow for mirror maker. By dot star, I'm saying I'm allowing all topics, and I have some blacklisted topics, which are internal. So once I do a Terraform plan, Terraform tells me that, hey, Dewan, like, these are the resources I plan on creating. Check it in case you change your mind. So I can go through the list. Some of the resources that our configurations will be known after runtime when I do Terraform apply. So here I can see that, OK, Kafka source will be created. Kafka target cluster will be created. So far, it looks good. Mirror maker will be created. So this is just to make sure that what I'm telling Terraform to do is making sense. So here are the source and target topics. The name of the source topic would be topic A. And the name of the target topic would be topic B. And here's the replication flow. So once all of this makes sense, I can go ahead and do a Terraform apply. A Terraform apply will actually create the resources. So once I do a Terraform apply, I have to explicitly say yes. And then, hopefully, we'll see the 3 resources being created shortly. So if you see that the prod dash in front of every name, that's coming from a variable file. It's just showing good practice of using configuration. One disclaimer that I did an 8x on the time. So if you're seeing that it's created in 2 seconds, the Kafka cluster doesn't get created in 2 seconds. I did an 8x on the service creation just so that you don't have to wait while the services are created. So now that the 3 services are created, I'll go into the topics and see if the topic exists. I don't see any topic. What's going on? And I can go to the different service. Oh, I can see that Terraform is still creating resources. So while the services were created, the topics and the replication flow, these are separate resources. So Terraform is still creating those resources. So that's fine. Let's give Terraform a few more seconds. So I'm going to my mirror maker service and going to replication flow. And I see the replication flow is still being created. So once I wait a few more seconds, hopefully all the resources are created by then. So now that the resources are almost created, I can go to my Kafka source, and I see that the topic A is created. And I'll go to my mirror maker service and see in the replication flow, I see all the service integrations between the source cluster and the mirror maker is running. And now let's go to the target topic, and I see source.topic-a. Source means my source Kafka cluster. I already see that topic B exists, but now the topic A from the source Kafka cluster exists. So this was the quick demo. So just to recap what we did in this demo is we declared all the resources using Terraform. We followed the 5 best practices for infrastructure as code tooling. There are a lot of Terraform best practices, but that will make this a talk on Terraform, which is it's not. But from the data infrastructure side, you have declared all your resources, and you can make sure that your services are running. It saves you a lot of time, but more importantly, it gives you a consistent practice. Now you can ask, but Dewan, like, how do I start? I have a suggestion, but again, that might vary based on your use case. The first step is always the research. Is this right for us? Kubernetes is very hot, but whenever people talk about Kubernetes, it's not a silver bullet. So you can replace Kubernetes with any technology. Nothing is mandatory for you. You should do your research and see if this is the right fit. The second point is awareness. Remember the first concern for infrastructure as code, resistance to learning? Awareness is very important. You should have a discussion with your architects and engineering teams if you're ready for that. Even if you did your research and found out that the tool is perfect for you, if you don't have the buy-in, it will be very difficult to roll out. So that awareness piece is critical. The third point is the principles. Do you know the fundamentals, the basic blocks to get started? Of course, the book is a great resource. I also have a blog on this on my personal website. I'll link it at the reference section. The fourth point is pilot. As engineers, we love to play with stuff and build something. So that gives us the confidence. So once you did your research, you have the buy-in, and you understand the principles, build something. It doesn't have to be production. It could be a small pilot project for your dev environment and really see the tool in action. And the last point is going all in. Just kidding. Don't go all in. The last point is strategy. Roll out where it makes sense. It might make sense for a small subset in your organization, and this is perfectly fine. But this is a suggested approach to get started. So to recap what we discussed today is we talked about the infrastructure as code principles, but more importantly, we talked about the challenges and concerns when applying infrastructure as code principles for data infrastructure. We talked about a suggested approach on how you can get started on your infrastructure as code journey. So these are the references. The first reference is for Ivan Terraform provider, what we talked about today. It could be any Terraform provider as long as it gives you a sense to build and rebuild services programmatically. The second link is the demo. So the demo I showed you today. So this is a detailed blog or a cookbook recipe where you can play and do it yourself. And the third one is an infrastructure as code blog. So this is on my personal website. It's again inspired by the book, so a very small subset from the book. To highlight what we discussed today focuses on very specific cases of data infrastructure. There could be more challenges when you're doing infrastructure as code on data infrastructure, as I couldn't cover everything in these 30 minutes. If you have any questions, please ask me now, or maybe shoot me an email if you're feeling shy. I have one small token gift if someone asks questions for them. I have some stickers if you're into nice crabby stickers. But again, thank you so much for your time. It feels fantastic to be presenting in person again. And if you have any questions, please let me know.